Let's move to homeostasis. Homeostasis came from the word homeo, which basically means the same, and stasis, which literally means staying. What it does is to maintain a relatively constant environment within the body. It is usually within a narrow normal range and fluctuating around a set point. And so as you can see from here, we have our body temperature, which is at normal range, set at 37 degrees Celsius. And then below, we have our temperature badge that shows 36.5. So my temperature at that point was below the normal range. Remember that our cells require relatively constant environment to function properly. And so our body has to maintain its internal environment against a constant fluctuating external environment. Deviations from homeostasis can lead to malfunction of cells and even cell death. Homeostasis is typically maintained by feedback mechanisms. So what are feedback mechanisms? We have the negative feedback and we also have the positive feedback. And the components of a feedback mechanism, we have our sensors or our receptors, which is a component of a feedback system that monitors a physiological value. And then we have a control center, example would be our brain. This is a component of a feedback system that compares the value to the normal range. And then we have the effector, example would be our sweat glands. It is a component in the feedback system that causes a change to reverse the situation and return the value to the normal range. And then down here we have our negative feedback mechanism. It's a mechanism that reverses a deviation from the set point, and it maintains body parameters within its normal range, and it goes on throughout the body at all times. Now let's look at the negative feedback loop. We start with the stimulus, and then the stimulus will give a signal to the sensor, and then from the sensor it will move to the control center and then to the effector. And it goes into a loop. From the effector, it will send the signal again to the stimulus, and it goes on and on. Then let's move to our example, body temperature regulation. A while ago, in the photo that I've shown you, the temperature is lower than normal. Normal setting is 37 degrees Celsius and it was 36.5. While in our case, in our current example, body temperature exceeds 37 degrees Celsius. Let's just say 37.8 degrees Celsius. And then what happens next is that your nerve cells in the skin and the brain will sense that the temperature is higher than normal. Then what your body will do is to regulate the temperature by sending a signal to your brain throughout the day to adjust and regulate the temperature so that it goes back to the normal temperature, and it goes round and round. Then we have our positive feedback mechanism. The system responds by making the variable deviate further from the normal value as the response occurs in the same direction as the initial disturbance. Positive feedback does not maintain homeostasis and rarely occur in healthy individuals. An example would be childbirth and the body's response to blood loss. You have a positive feedback loop that are normal but are activated only when needed. An example would be head of a baby pushes against the cervix, and then your nerve impulses from the cervix is transmitted to the brain. Then your brain stimulates pituitary gland to secrete oxytocin. And oxytocin is carried in the bloodstream to the uterus, And then oxytocin stimulates uterine contractions and pushes the baby towards the cervix. And it goes round and round until the mother's bundle of joy comes out. The standard body map or your anatomical position is like in the photo wherein the man is standing upright, feet at shoulder width and parallel, and the toes are facing forward. That I would like to introduce two directional terms. On the left side, you have anterior, where the man is facing in front, and then the right photo, we have a posterior, wherein the man is facing at the back. We have more directional terms here. In this photo, you have the superior, which is basically an arrow that shows above, and then inferior is a direction that actually shows going down or below. Then we learned about anterior a while ago, which is just facing in front, and then posterior is facing at the back. Then you have proximal, which is close to the point of attachment, and then you have distal, which means it is far from the point of attachment. Then you also have superficial, which means close to the surface, and deep, which is towards the interior of your body. Don't be confused of these terms. I will be giving you examples and a summary later. And then we have here the supine, which is a horizontal position with face oriented up. Then we have prone, a horizontal position, or you are just basically lying down with your face oriented down. And then you have your right lateral recumbent, which is a horizontal position with right side oriented down. And then you have your left lateral recumbent. You are in horizontal position with left side oriented down. And there are other common positions that including Trendelenburg's and Fowler's position. Here is a summary of the anatomical terms. We have the terms, and then next will be etymology, and then your definition. And I believe you already know where is your right and where is your left. When you are directing towards the body's right side and you are directing to the body's left side, that is self-explanatory. So you can just say the right ear or the left ear. But when you say inferior and superior, inferior basically means lower, and then superior means higher. Inferior means lower or below, and then the nose, you can just say the nose is inferior to the forehead. And then superior means higher or above, wherein you can say our mouth is superior to the chin. And then for anterior and posterior, anterior means to go before or towards the front of the body. Remember a while ago, it's facing in front. So the teeth are anterior to the throat. Posterior, from the word posterus, which literally means following, you are basically directing towards the back of the body. So the brain is posterior to the eyes. Then you have dorsal and ventral, from the word dorsum, which literally means the back, and then for ventral, came from the word venter, which means belly. Dorsal is just another word for saying posterior, and ventral is another word for anterior. So basically, dorsal is another term that you can actually use to replace posterior, and then ventral is another term that you can actually use to replace anterior. Okay? So the spine is dorsal to the breastbone, and your navel is ventral to the spine. Then you have proximal and distal. All this etymology is either Latin or Greek word, okay? So we have proximus, which literally means nearest, and then for distal, it's a combination of the words di plus sto, so it means to be distant. When it is closer to the point of attachment, you can say the elbow is proximal to the wrist. But when it is far or farther from a point of attachment, you can say the knee is distal to the hip. Alright, so then you have your lateral and medial from the word latus or side, and then medialis, which means middle. When your body part is away from the midline, you're referring to lateral. When it is towards the middle or midline of the body, you are referring to the medial term. Okay, so the nipple is lateral to the breastbone, and the bridge of the nose is medial to the eye. You can either describe something as superficial or deep. From the word superficialis or surface, and then dio, which literally means deep. So when it is toward or on the surface, that is superficial. The skin is superficial to the muscle. When it is away from the surface or internal, the lungs are deep to the ribs. Then you can say deep. Alright? The anatomical term is deep. All directional terms refer to a human in the anatomical position. So don't be confused when you describe something. Just remember that the standard is your anatomical position. Then we have our body cavities. Our bodies has many cavities that contain and protect delicate internal organs. Some are open to the outside of the body, just like here you have in the photo, you have your nasal cavity. Some are open to the outside of the body, just like your nasal cavity, and some are not open to the outside of the body. In our photo, down here we have our thoracic cavity, abdominal cavity, pelvic cavity, pericardial cavity, pleural cavity, and another example will be your peritoneal cavity. Now let's move to the thoracic cavity, composed of your heart, lungs, thymus gland, esophagus, and trachea. Then you now have your abdominal cavity, composed of your stomach, intestines, liver, spleen, pancreas, and kidneys. Next, you have your pelvic cavity, composed of your urinary bladder, reproductive organs, part of the large intestine. And then you have your pericardial cavity, which is around the heart. And then you have your pleural cavity, which is around your lungs. And then next, you have your peritoneal cavity or peritoneal cavity around abdominopelvic cavity. Answer. Now, let me check on whether you know the answer to these questions. Okay, question 1. Our navel is located in the blank side of the body. And then question 2. I'd like you to identify the type of mechanism when the level of insulin will rise under certain conditions but will soon drop to normal level in the presence of another hormone called glucagon. This process typically occurs throughout the day. Check your answer whether you got it right or wrong. For number 1, our navel is located in the anterior side of the body. Remember, navel is the belly button and it is on the front side of the body. So that is in anterior. And then for question 2, it's a negative feedback because the level of insulin rises and then falls, or it fluctuates all day long. It is called negative feedback mechanism. So I hope that at this point you can now define anatomy and physiology, and then you can discuss the levels of organization in living organisms, Then you can state various organ systems and their functions. Then you can now describe the mechanism of homeostasis. And now you can list anatomical terms to describe body sections, body regions, and body cavities. Thank you so much, and I'll see you again next time.